Say hello, Chris.
Hello.
There we go. Looks like I'm seeing your audio and they can hear it. So
Great. What do you use, OBS?
I do, yeah.
Okay, I use OBS. It's a complicated tool to learn.
It is, yeah. So let me see. I'm going to try to resize a little bit here. There we go.
So how did you hear about me? Because when I came on your channel a week or two ago, and you saw my name in chat, and you knew who I was, but I honestly I'd never heard of you. I don't know how I came across your live stream at the time, but was you see me on not?
Yeah, I saw you on Non Sequitur with I don't know. Who are you on with? Team Skeptic?
I've been on with Godless Engineer, Fight the Flat Earth, and then Godless Engineer again with Kyle.
Okay.
I was on Team Skeptic show a couple times, yeah, afterwards.
All right. So, and you gave your background, I think, a little bit on one of those. Do you want to say anything about what your background is? Or what you do?
Yeah, I mean it's basic. It's just a basic flat Earth story. I came across it on a YouTube video, and honestly, it's been so long. I don't remember if I came across it like on a suggestion, or if I heard someone like Eddie Bravo talking about it on Joe Rogan show, or what. But something like that. And of course, I watched the video, Eric Dubé's 200 proofs Earth is not a spinning ball, and I don't care who you are. I mean, one of the 200 proofs is going to be intriguing, right? And if you say it's not intriguing the first time you watch it, you're lying, in my opinion, right? I mean, there's some things on there you watch, and even if you said, "Oh wow, I wonder what the heliocentric answer is," right? You still went to look for the answer, right? And that's kind of the thing that got me, is I had to go look for the answers because I didn't know. And really from there, I just did all the research. And of course, people say, "Oh, well, YouTube, huh?" But like, yeah, I watched a lot, like hours and hours and hours of videos on YouTube, and did research online of those things, research on gravity, research on the formulas of curvature, or all those things. So, long story short, that was 2.5 or 3 years ago now, and yeah, I mean that's really it. I mean, I could keep going, but it's a basic flat earther story, I believe.
Yep. So yeah, I watched 200 proofs. It took many sessions because I fell asleep, and then I fell asleep again, and then his voice gets a little drony. You gotta admit, like him or not, that voice. So yeah, every one of those I saw, I'm like, that doesn't make sense. I don't know if that's true, and when I looked it up, I'm like, oh yeah, that's not true.
Yeah, fair enough. But again, it made you question enough to say, "Oh, well, I want to see what the real answer is." Because even if you said you don't believe his answer, you still had to go and look up the quote unquote correct answer yourself, right? I mean that's the point.
Sure, for some, yes, absolutely.
Right. So I mean, there's things on that video to this date that honestly, and I'm speaking non-biasedly as much as possible, or unbiased, whatever the word is, that there's things on that video to this day that I don't know what the true answer is. Like, for example, the horizon rises at eye level. I do not know what the truth is, because I've seen things from ballers that show it not rising, and I've seen things from flat earthers that do show it rising. But there's a guy named Mind Warped. He's in Australia, and he's got a drone that he takes up like 400 or 500 meters or whatever it is, and the horizon absolutely rises with the drone, right?
So
I'm like, well, how?
The problem is that's not very well measured.
Well, no, of course not, but none of them are.
Oh no, there's plenty that are well measured. Right?
Well, they're well measured, but there's no validation or verification like the ones I've seen that use like those water levels and things. Okay, that's good. It's a good interesting measurement, but what else could be at play, right? For example, refraction. We know refraction can cause things to to be hidden, so to speak, around a curve or in general, and that's called what was it? God, now I forgot. I'm tired. It's almost 10. Shrink. Was it shrink? Atmospheric shrink or refractive shrinking? Or no, sorry, sinking. So there's a refraction term called sinking, and to give you the unexact and definition, from what I remember, it's basically refraction pulling things down to make them disappear out of sight, basically. So my point is if you saw something at the horizon, 20 miles away in some of these videos, and it doesn't rise, it could just be refraction.
It could be. All right, so let me see if there we go. So here is do you see that there? This is on my website here, MCToon.net/horizon does not rise to eye level. It's on just on the main page if you want to scroll down.
Sure.
So here is a
setup. Wait a second. So we're supposed to believe the horizon should be where the top of the two red water lines are?
No, not at all. This is the setup.
Oh,
right.
Okay.
This is the setup. This is just a close up of the setup. So this is by Bobby. Oh my goodness, why did I forget his last name? Bobby Shafto.
Okay.
He did this. He lives down somewhere near San Diego. So this is off somewhere in San Diego, and you can see these islands in the background of the Coronado Islands. So here's how he did the photographs, right? He had a camera there on a tripod. He had the tripod holding up the water levels. So now here is from 90 feet the tops of the water is lined up, and you can see the horizon didn't rise.
Well, okay, but it's semantics, because it does rise. It's not maybe the answer is it's not rising to eye level, but it does rise. If you lowered that camera, the horizon would lower, and if you raise the camera, it will raise. It's like I've seen comparisons of people on ground in a plane, and then that same person in the air, 35,000 feet, whatever, and the horizon is at the same level it was when it was on the ground. So how would you explain that?
I would explain that they didn't measure it well, because on the plane they didn't bring any equipment to do a quality measurement. Right? I've seen plenty of people just point a camera out the window of a plane. But I have also seen people use the Theodolite app on a phone, and the horizon doesn't rise. And I've seen people bring, like Planer Walk actually brought a small level with them on a plane and use that. It's much less quality to have a small level, right? Because the margin of error is a little big. But at that height, it's enough of a distance that even with the margin of error on a small bubble level, you can see it. Right?
So do you know? Okay, so I'm going to ask you a question. Okay, where is the horizon in the image you have on screen right now?
The horizon is below those two red lines, and you can see there's a ship. The horizon is past the ship, and the horizon is before the Coronado Island there.
Okay, so let me ask you a secondary follow-up question. How do you know that's the true horizon?
Well, are you going to say that there may be some optical effect that's making us not see the true horizon?
Yes.
Yeah. So that would be this image, as well as others that Bobby has taken, where you can see things behind. This one isn't any, but this is the same day, I think, as that one. But let me see. This is a different day here, and yeah, this one's good because you can see the texture of the clouds below the true level there. So in the sky, you can see the texture of the clouds.
I mean, is it zoomable, or like can you zoom in on it?
This is as far as this particular image goes. Yeah, and he uploaded these. He has higher res of these. I should ask him for for these.
I'd like to see them zoomed in, because honestly, like right now, if you look at that mountain that's kind of in the middle to the left, it looks like the bottom of that mountain is missing. Like you can there's a distinct clear line below,
Sure.
and then it's and then darker.
Yeah, but that's also quite a bit below the true level line there that he has in the middle of the that grid box.
Yeah, fair enough. But I mean, it's, what one thing is telling me is that there is refraction at play, and then two, what I do know for a fact is refraction gets worse the further out you go, because obviously if you have a column of air that you're looking at, right, that air is going to just become more. It's become more. The density is the same, but because you're looking through more of it, it's gonna be more dense basically. So
Now what does
go,
density do?
It's going to make refraction worse.
Yes, and what happens when you have a refraction in air, right? Because we have from altitude, and this is taken from 100 feet. What does the density gradient do?
Wait, so
to light?
I'm not. What is the density? Well, it depends on the temperatures and those kind of things.
No. Yeah. So let me rephrase as, what does an index of refraction gradient do? If the index of refraction is lowest at the bottom and increasing and decreasing, I said it wrong. It's the highest value at the bottom, and it's decreasing as you go up, right? So it's the lowest. I kind of messed that up saying it, but you understand what I'm saying? Should I say it more clearly?
No. Well, so no. Why don't you just tell me what I honestly, I hate, and I'm not calling you out, but I have people ask, like Bob the science guy does that, and it drives me nuts. He'll ask you a question, waiting for the answer. Like, just tell me what you're getting at, so we don't have to play the cat and mouse thing.
So here's some numbers. The index of refraction, just kind of the standard that they use, but it's of course varies quite a bit, is 1.00029 at standard conditions for temperature and pressure, which they've defined in this table here, right?
Okay, sure.
So it's just agreed upon standard. It's sea level. It's a certain air pressure, a certain humidity, a certain pressure.
Okay.
And then the difference, and then up high, as you go higher up, it goes to 1 or very close to 1. And that's not a big difference in the index of refraction. But when you go through a farther distance, a long distance of it, it makes a change, because a very small angular change over 10 miles adds up to being a lot.
Yeah, well, that's basically what I was saying, is if when you look through 1 mile of an air column, it's not bad. Even through 10 miles of that air column, it's much worse.
Yep. So here is Batman looking at a building here. This is with no air, basically, or no change in the index of refraction. Light would go straight. That same light ray, though, if the index of refraction were how our atmosphere is, where it's getting lower or getting more a higher index of refraction, as you go down, it's going to bend that light towards the higher index of refraction. That's what it does, right? So then there's a different so that original light beam wouldn't make it to Batman's eyes. It's going to curve and go off before it gets to him. So that the different beam of light that actually started out at a different angle is going to be what gets to Batman. Are you following along there?
Kind of, but not really from these pictures, just what I already know. So he's saying the top line will get to him, but the bottom line isn't going to get to him?
Yes. Okay. Yeah, because it all curves. So the original light beam from this one with that straight line, and I hope it shows straight on here through Hangouts. That one wouldn't make it because it's going to curve down and hit the ground or something in front of him. And then you've got a different light beam that started out at a different angle, slightly higher, that otherwise would have missed him. That's the light beam that's going to get to him.
Okay, well, so is this on a flat surface or a curve?
It doesn't really matter. if it's flat or
What's
curved.
the distance between Batman and the hotel? Because that hotel would have to be like many, like 20 or 30 miles away for him not to be able to see the top of the hotel.
Well, he can see the top of the hotel. There's no problem with that. It's that the light beam, the light that originates from the top of the hotel, has to start out at a different angle in order to get there. Right? So the top light beam, and it is a slightly higher angle than the bottom light beam, and that's what gets to his eyes because of the.
Can you
the
go
curve.
back? Can you just do me a favor? I don't know how much more time I have. Can you go back to that picture of the real picture we were looking at? I noticed something interesting on that picture of the horizon and the table, or the square and all that. The square box with the lines, whatever.
Yes. Yep.
So I noticed that it says, click on, so I noticed on the right it says apparent horizon. What's the apparent horizon?
That's what you see. So he's being fair and saying,
Okay.
and not calling it the horizon. He's calling it the apparent horizon. It's what you're seeing.
So why would it only be an apparent horizon?
Because he's being fair. He's not just saying it is the horizon. He's using words that are not going to cause people to have an issue with the word of horizon, instead of the point of whatever it is that we're looking at didn't rise up as is claimed.
Okay, so I mean, I then agree with this observation that the eye level is higher than the apparent horizon.
Yes.
So then the question is it the apparent horizon or is it the real horizon? And then how do we verify that?
Well, yeah,
claim?
and that's the question. And so that's why I'm doing this. We're looking at refraction here.
Sure.
So, if let's see, we're looking at.
So can refraction cause things to go up and down?
Refraction does it absolutely, but okay. For the most part, under calm conditions, it's a gradient mostly, from top to bottom, that doesn't have a lot of inversions. Okay, so when there's an inversion, then it starts throwing things off. Or if you have windy conditions and a lot of heat and the sun beating down, stuff like that, it can make all these things a lot more chaotic and makes observations basically so much in question that you can't really draw any conclusions. So it's best to have conditions that are not sunny, because that causes the causes the heat to come off of the water a lot. Yeah.
Can I share something?
Sure.
All right, let me share my screen.
All right, hold on.
So this is a picture that I took a snippet off of a video on YouTube that I can send you the link if you need it. But I was basically comparing the different sizes and shapes of the boat as it got further out. So I want you to note it. And by the way, can you see it first of all?
Yep.
Okay, so let me just zoom in a little bit. So there's a lot of things about this photo these photos that are really cool. But to this point, notice that on the image you were showing, I asked where the horizon was, and you said basically it's the hard quote unquote water line, or the blue water line. And then I asked how you knew it was the real one, and that even on that guy's picture it says apparent, and that's good because that's correct, because we don't really know, looking at those distances, where the real horizon is. And this video and these images show that perfectly, because you would just assume if these black lines weren't here showing where the inferior mirage starts, and if this boat wasn't here, you would say, oh, here's the horizon, when in fact the horizon is this much higher in the photo. So
I would say we don't know where the horizon is.
Well, I know where the horizon is. Right, it's where this black line is, because that's where the boat is right. The boat is rising because of perspective, and then basically you take the image and the further it goes, and you basically at this point you're going to cut it in half. So here, because it's rising, here's the horizon, because we see the boat is on top of the water here, and then it's still on top here.
Yeah, but I would say, and it doesn't matter much, but I would say that it's somewhere between the apparent line there and the line that was drawn in, that it isn't actually at the line that's drawn in, because there's too many atmospheric effects that are happening there that we don't know if there was some reflecting happening as well. Well, we do know there's some reflecting because of that inferior mirage. So what this does is that it puts the observation into question. And so when you look at something like this, you say, okay, this is the wrong day, the wrong conditions. Let's come back on a different time and have better conditions so that we can have less of this chaos.
Yeah, so that's another one of my pet peeves, because to me, there's never going to be... So the norm is these conditions. The not norm is quote unquote good conditions, right? I mean, you're always going to have atmospheric refraction, especially over water. Like, it's just going to happen. And the further out your object is, again, the worse the refraction is going to be. The worse the haze will be, the worse, right, the disappearance of the object will be, et cetera, due to the atmosphere. So it's just one of those things where I'm like, you can't get around refraction. You might try and find a day where it's less, and that's fine, but you see what you see with refraction.
Yep. And so that's why, in general, I really don't prefer using optical things over water, because for everything that you can find that looks flat, I can show you something that looks curved, and in the end we make no progress, because it's just this back and forth.
Right, but you're using those level experiments over water to prove that the horizon doesn't rise to eye level. You see the problem with that?
Well, I was simply refuting, because you started talking about 200 proofs, and so I went to number 2, which is, the horizon rises to eye level. And in fact, I've never seen it once measured rise to eye level. So if you've ever seen it measured rise to eye level, I'd love to see it.
Well, but you're saying even measured, we don't know if that's the real horizon, and
correct.
This image proves that. So why are we using that as an example at all?
Why is exactly? Why do flat earthers say that? Why does he not take it out of his video? His channel was deleted. He re-uploaded the same video, and he didn't take out that bad measurement, that bad claim. It's his claim number 2. And so it is just demonstrably false. Never does the horizon rise to eye level.
Remember, I started the conversation by saying that I don't know the truth, because I do know the horizon rises, but to what extent? Is it not perfectly to eye level? Okay, maybe, but does it rise? Yeah, it rises. And if you say it doesn't, I mean, that's just false, right? So like you said, maybe it's somewhere in the middle. But again, you have it on your website as a proof. He has it in his video as a proof. So
I have it as a disproof.
And you have it right. Yeah. You have it as a proof that the horizon doesn't rise.
Yeah, and that's because it's just such a often repeated trope. So, so my point really is, don't use it. It's not useful. So.
Well, but I would say that, and I hope you got my point in all this. I would say the same thing to you.
What?
Not to use those photos of those water levels staring out over the ocean.
Sure, let's move on.
Are you going to take those off your website?
No. As soon as Eric Dubay stops making the claim and other flat earthers stop making the claim, it'll be useful until then. Right? But because it's easy to just say, look, it never rises, and so you can't actually you can't use that as a proof for flat Earth. At best, it's a nothing, right?
You can't say that again. You can't say it never rises.
I've never once seen it rise to eye level when it's been measured. It rises, absolutely. Okay. But it doesn't rise to eye level ever, ever. And so as long as Eric Dubay is saying it, I'm just going to leave that page up to say it doesn't rise. So move on to something more meaningful, right? Make sense? I'm happy to leave it because it observations over water is subject to aggressive refraction. So.
Well, right, but see, I feel like you're either making my point or missing my point, because if the point is that there's major refraction over water, but you're using evidence over water to prove the horizon doesn't rise, then isn't that sort of hypocritical a little bit?
Well, we didn't get through my other point, which is about refraction, and that refraction will cause things to appear higher, which is a double blow.
No, but not according to the image I just showed. It made the apparent horizon lower.
Yeah, and I'm talking about in non-chaotic conditions.
Well, but why are those conditions chaotic and in yours they aren't? Like, what proof do you have of that claim?
Well, we know
that to me is just a boat on the water on some sunny day, right? I mean, why is that chaotic?
Oh yeah, because people understand what causes aggressive chaotic refraction effects and what doesn't, right? We know that a sunny day causes heat right over the water and sets up reflection layers and aggressive refraction effects. So that's a something you don't want to use, right? So let's move on from that then. What do you have that makes you think the Earth is flat?
So my big thing is ground level observations and measurements. I don't go to the sky. I'm not, like, if you were to ask me, how does the sun work? How does the moon work? Well, I could give you the standard flat Earth answer, but that's just not it's not my interest. It's not what I've researched. I don't really, I just don't, that's just not what I do. But basically, the ground, ground level, water level, whatever you want to call it, sea level, observations, measurements. Like, for example, one of the last tests that one of these flat Earth groups did in California was they did two 18-mile or almost 18-mile observation measurements. They used a standard laser light, and then they used the mirror. Well, but you asked me why I thought the Earth was flat.
Yeah, but we had already decided that observations of light over water was not going to be conclusive, so we should not use that.
Well, they've done laser tests over land too. I think I'd have to look because most of them are over water, because people, because over land you could argue, well, it's just like hills and mountains and things.
Yeah,
but over water, the theory is the water is either flat or it's curved, right? There's minor undulations, say, in the waves, but in theory, it's either a curve, or curving away, or it's flat across. So I think that's where a lot of people were going for the water tests.
Okay, so do you have something that's not light over water?
That's not light over water. Let's see.
You can't have just like one thing, because that's the deal. Light over water is one thing, and when you're examining something to find out what's going on, you build up your proof, right? Your different evidence is not proof.
Well,
you take off.
You have to realize that to me is one of the it's
but it's
more
one.
Interesting.
But it's only one.
Well, no, it's not one. It's many different pictures, videos.
When you do science, you take a whole bunch of measurements of the same type of experiment, and that's one thing, right? And then you take a different type of experiment and you do a whole bunch of measurements, and that's another type. Now you have two things, right? So, and you put them into the bucket that supports or doesn't support. So, observation, lasers over water. Yeah, that's what all the flat earthers want to do. And it's one thing. At the end, even if it works right, even if it's well controlled, you have one thing. So what about other things? What about gravity would pull a flat plane into a ball?
Well, see, and that's the thing is, I'm like, I can talk gravity some, but it's just not. It just doesn't interest me. It's another one of those things where, to me, we're basically at a stalemate. There's no scientific proof for gravity. There is an effect.
Hold on.
But it's
hold
only
on.
one
Hold on. Just
thing.
wait. Name one thing that's been scientifically proven.
Water boils at 100 degrees centigrade
That
at
is
1 atmospheric pressure.
that is a definition.
What do you mean it's not a
They
definition
decided that let's boil water, distilled
No,
water,
they didn't.
and look up the history of how the centigrade scale came to be. They boiled water, and when it boiled at 100, they marked it 100 degrees.
So you don't think that someone somewhere came across a hot spring, a natural hot spring, and said, "Wow, I wonder why that hot spring is boiling like that, or steaming, or whatever they do"?
That has nothing to do with how they defined the centigrade scale. They defined the centigrade scale by saying, we're going to choose something that everybody can replicate. We're going to take distilled water at standard pressure, and we're going to boil it. And then we're going to put a mark on the thermometer there, and we're going to call it 100 degrees. It's arbitrary. Then we're going to do the same thing with the same water at the same pressure, and we're going to freeze it. And when it hits zero, or when it freezes, we're going to mark 0 on there. And then we're going to put 100 even lines on that thermometer. That's how they got the centigrade scale. So it's not proof.
I think you're missing my point.
No, it is not proof that water boils. It's a definition. It's an arbitrary definition. So that's not a scientific proof. So what has science proven?
Well, so I don't agree with your analysis. So I come across a hot spring. I wonder why it's boiling and steaming. I then make a hypothesis that what I know about heat and energy and those kind of things, and I say, well, I wonder that if I heat this water, will it boil that same way? And by the way, I wonder how hot it has to be to boil. So I can make a hypothesis, and just for sake of time and argument, I'm going to say if it boils at 100 degrees centigrade, or if I get it to 100 degrees centigrade at 1 atmospheric pressure, it will boil. I then perform an experiment to test my hypothesis. I put it in a beaker. I turn the beaker up. I put a thermometer in there, and then the second it hits 100 degrees Celsius, it starts to boil. So I have a natural observed phenomenon of the hot spring boiling. I have a hypothesis as to why it boils. I have an experiment based on the hypothesis, and then I have my confirmed results based upon the temperature that it hits when it starts to boil.
All right, none of that matters. None of that matters because the Celsius scale was defined by putting a mark where water boils and a mark where water freezes. It's a definition. It's an arbitrary definition that they just made. So you cannot prove that water boils at 100 degrees. That's not been proven. It's a definition. So what has science proven?
So by that logic and argument, then there's no measurement ever taken that's accurate or can be proven. It's just based on your...
Absolutely correct. You got it right. There is nothing in science that has ever been proven.
Okay, so what's the point of all this then? I mean,
well, so I just want to have a
ground or flat.
I just want to have a common understanding, an accurate understanding between us, because a lot of flat earthers like to talk about proof. You don't have proof of this, you don't have proof of that. We don't have proof of anything, and we're happy that we don't have proof of anything because that's not what we're looking for. Science doesn't prove. Science can disprove, and science can build up a lot of evidence. That's what it does.
So you have no proof of a spherical spinning Earth, then, correct?
Correct. I have lots of evidence.
Okay. Well, I have lots of evidence for a flat Earth. Then.
Okay, good. So we're on the same, right? We're talking how science talks and not how, you didn't prove this, therefore you got nothing, right? And so the other is people talk about theories and they're like, oh, it's just a theory. It's not just a theory. So a scientific theory is a rigorous thing that has come up after lots of experiments that's been pulled together. So when somebody says just a theory,
though, right?
Of course it's not proof.
Okay.
But a theory doesn't come about just haphazardly, and it's not a hunch. And so when somebody says it's just a theory,
well, it is a hunch. It is a hunch based on the apparent.
No. In science, a theory is not a hunch. There's no correlation between them. Then you don't understand science.
No, I do understand. It's a hunch based on the evidence observed. It's a guess based on the evidence observed. You just said there's no proof in science, but now you're saying that it's evidence based on what? Proof?
No. Just a second. just a theory. So there it is. An article here. I like this one. I'll post it in chat here. Why anyone who tells you science doesn't prove things impartially doesn't understand science. Now, we've moved past that, so that's not important. But I just thought I'd add it. I have too many references here. A scientific theory is an explanation of some aspect of the natural world that has been substantiated through repeated experiments or testing. So, there is no...
What experiments have they done with evolution?
All right, so we're just defining terms at this point, okay? So I put in, that's from Scientific American, an article in there that goes over seven different things in science.
Sorry, can you go back and let me read it again, or let me read it again? I just want to make sure I'm clear on it.
Sure, I'll pull it up on the screen. There you go. There you go. Scientific theory is an explanation of some aspect of the natural world that's been substantiated through repeated experiments or testing. But
Okay.
to the average Jane or Joe, a theory is just an idea that lives in someone's head rather than an explanation rooted in experiment
No,
or
see,
testing.
I gave
that's
you
the wrong
basically
part.
I gave you basically the exact definition of scientific theory. I said it was a guess based on observed evidence.
No, it's not a guess.
It is a guess.
It's an explanation of some aspect that's been substantiated through repeated experiments or testing, right? This last sentence, but to the average Jane or Joe, it's a theory, is just an idea that lives in someone's head. And that's wrong. That's the point of this. It's wrong. It's not a guess. And it is, in fact, something that has been repeated and substantiated through testing. So many experiments come together, and when they are in agreement with each other, then you have a scientific theory. Right? So they say the theory of relativity.
Yeah, I agree with that, yeah.
Okay. So the theory of relativity isn't a hunch, right? It is something that's been substantiated through repeated experiments.
I don't know. I mean, I don't know that to be true. I've not done enough research on relativity to see.
LIGO. Look at LIGO. That's a great
What
place.
does LIGO have to do with it? I know what LIGO is. What does it have to do with it?
Because what has come out of LIGO is very much right in the middle of the theory of relativity.
They're just shooting particles at near the speed of light at each other. What does that have to do with?
No, that's maybe you're thinking of CERN. LIGO is two 90-degree lasers going over many kilometers and bouncing back, and they're measuring gravitational waves.
Yeah, but you said earlier measurements that we can't really rely on measurements because it's just an average, or no, I forgot what you call it. They're just setting the standard. So anything to do with measurements, including Cavendish, including LIGO, including CERN, we have to throw out of our discussion.
No, I'm telling you that water doesn't boil at 100 degrees, and that's proof. Water boils at 100 degrees because that's a definition. It has nothing to do with anything outside of.
That means all measurements would be definitions.
No. When you look, so saying that water boils at 100 degrees is similar to saying that the length of a meter is proven to be, and then whatever the length of the meter definition is. Right? There is a definition for the length of a meter. It's one of the fundamental units that people have defined. Right?
Right. So
but when
I'm 6 foot 2 inches based on the standard measurements, you're going to say that I'm not?
I'm going to say that is accurate within a margin of error, but that's not an experiment, and that's not the type of thing that we're looking at when we're saying we don't prove things. Right? So, you aren't 6 foot 2. You're 6 foot 2 within a margin of error. And if you were to find a better measurement tool, you could find that you're 6.2 something. And then that still would be improvable. We could find a different, more accurate way to measure. right? So, but that's beside the point. That's I'm just saying that the point is, I asked for proof. What has science proved? And you said what I knew you'd say, which is water boils at 100 degrees, and that is not proof. That's a definition. So there's nothing that science has ever proven. There's always a what if to science. Right? So what if the Earth is flat?
So these theories you're showing on screen aren't proven.
Correct. But they're supported through repeated experiments and testing.
Right, but they've not been proven, so they could be false.
Absolutely.
Okay.
And if you want to make yourself some notoriety, go pick one of these well-established theories and disprove it.
Well,
then you'll get a Nobel Prize.
A lot of people who don't believe in the theory of evolution. So I mean, it's not something that's new
Sure.
or that's like controversial. It's there's millions of people, including smart scientists and PhDs and people like that, who don't believe in the theory of evolution. So, I mean, I don't know what to tell you, right? It's again based. So one thing I like to say, like when I'm on Jose's or whoever, I say I'm not here to prove anything to you or to demonstrate anything. I'm here to demonstrate alternatives for those who can't think outside the box or who haven't seen the alternative evidence. So, for example, when someone says, "Look, the horizon doesn't rise because someone took a picture and they drew a line," I then say, well, the alternative could be that refraction caused an apparent horizon, and now you can't see the real horizon. And then I show that with other observations, right? So, I mean, this is you're stating your case, I'm stating my case, and at the end of the day, it's just about an alternative explanation.
Yes, and the deal is, of course, to come up against things that have a lot of evidence and repeated experiments is tough to do, and the reality is that science is welcoming to that, and like I said, the people that have been the most popular scientists are the ones that came up against a popular, well-held theory and disproved it, and then those are the people that they're celebrated, because that's an advancement. Right. So
I don't agree with that, but I don't agree with that.
You don't agree that people are celebrated when they upset the existing theories? Einstein did exactly that. Einstein did exactly that, right? He came out when Michelson and company were saying it's all about the luminiferous ether, and they had done some tests and it wasn't working. They weren't finding any ether. And he came out with his theory of not evolution, his theory of relativity, and they didn't like it at first, and he had to go back and forth a lot with them, and it wasn't for quite a while until some experiments were done to confirm it. But eventually, it completely removed the previous ones, upset them, and now we talk about Einstein, and not many people know about Michelson. Now, Michelson got a Nobel Prize himself for his work on light. Even though all of the stuff that he was trying to discover about ether, he didn't succeed in. But he advanced the understanding of light so much that he got a Nobel Prize for that. So there is an open invitation to anybody to disprove. But it's not just ideas or incredulity that does it. Right? It takes rigor.
Like there's a story, and I haven't heard it in a long time. I'm trying to Google it. There's a story of a woman called, what is it? Mary. I was trying to see it on here. No, it's too long.
Curie?
No, it's recent. It's like Mary Schweitzer. She's a PhD scientist at North Carolina. She found a dinosaur bone that had living or soft tissue in it, and they, of course, dinosaurs are 60 plus million years old, but you can't have soft, I don't know if to call it living, but soft tissue in a bone that old. And she tells a story about how when she discovered it, she just was basically completely panned, and she was trying to tell everyone about it, she got panned and ridiculed and mocked and all those things. So it's absolutely not true that if you upset the apple cart, are you going to be welcome? Like you have to go through an extremely arduous process and kind of a thing to be to go through that. And I mean, it's just not. It doesn't follow, right? It's like, if I can show one case where that's not true, then it's a non sequitur. It's like, well, it's possible that they're celebrated, but it's possible that they're ridiculed and mocked out of their job. So that's just
sure. Yeah, you're upsetting, and Einstein didn't have an easy time either, right? So here's Mary Schweitzer found collagen fibers in a fossil-like leg bone. They're rare and only occurred within extremely well-preserved fossils. So this isn't saying anything about any challenges that she had.
Yeah, you'd have to listen to her. There's probably videos on YouTube that you could watch or whatever, that her talking about it. Like I said, it's been a couple years since I've seen it, so I don't remember all the details, but she kind of gave a little bit of an overview and sort of how that went down. But
yeah, so she has received awards for her work in paleontology. She's been the keynote speaker and presented her research. She's been in the Nature Communications Journal for her groundbreaking work in MB and her role in establishing the field of molecular paleontology. So it looks like she's been quite celebrated.
I think that was
right. Certainly,
before.
Yeah, she may have had issues coming up and upsetting the cart, but she came out with these awards, so good for her.
Sure. But I mean, I don't know. Maybe I'll have to find a video of her talking.
Yeah, that'd be good.
It's just more apropos to the discussion, but.
Yep. All right. So do you have anything other than observations over water?
So there's a positive and a negative claim on the table. Okay, you're making the positive claim that the Earth is round because all observation and all a natural observation is flat and stationary. So if you were to ask me why I say it's flat and stationary, well, that's just the natural observation. To make the positive claim that it's round, you have to bring proof to the table, right? So in that sense, I've not seen any proof, or I don't like the word proof. I've not seen any evidence that the Earth is round and spinning and moving in all these directions and speeds. So I don't know how to prove the Earth is flat. I don't know how to prove the negative, so to speak.
Yeah. So of course this is CGI, right?
Of course,
from 1972.
Yeah. When they started to do manipulation with photography, right?
Yeah. So you have forensic evidence that this is CGI.
No, not forensic evidence, but it's
okay. So you just have
you've been able to manipulate photos since the late 1800s.
Yeah. So you have incredulity. That's all you have. Right, you don't have any evidence that this has been tampered with.
Of course, there's evidence.
Where? Evidence that this has been tampered.
Or when you research like blue marble and you find out that it was 100% CGI. It's layered images.
No, this is from 1972. This is the blue marble taken December 7, 1972 by the crew of Apollo 17.
Uh-huh.
Okay, so do you have evidence that this has been manipulated?
Well, first of all, you have to prove that they were in the vacuum of space.
No, I don't. You're shifting the burden here. All I need to do is say that this is a picture that they took, and so I don't need to prove where they were or anything like that, right? You need to disprove now. This is a picture. You need to disprove.
Well, you said there's no such thing as proof, so.
Yeah.
So it's
So
not proof
you need
of
to disprove.
all Earth. What am I disproving of? It's a photograph from a place you can't go.
Well, 3 people were there at the time.
So have you seen that? I don't know if they call it a documentary or a conspiracy theory movie. I think it's
Something
called
happened on the way to the moon.
Yeah, exactly. And in that documentary or video or whatever it's called, they show those astronauts in whatever spaceship or whatever they're in, and they have their window taped off to make it look like they're taking a picture of the Earth from 100,000 miles away or whatever. And then they leave the camera on, and the guy takes the tape off and turns the light on, and you can see more of the Earth exposed. So you would have taken that photo and said, look, here's a photo of the Earth from 100,000 miles. And if that video didn't exist, we wouldn't have any really good argument, because it's a real video, probably of the real Earth. But it's not a photo of the Earth from 100,000 miles like they claim, right? So it's not an argument to make or do. It's an argument based on facts and evidence that we have against NASA and astronauts.
I don't see how that follows. I don't see how any of that disproves this photograph.
They fake stuff. That's how it follows.
No, that's just poisoning the well, because you claim that one thing is faked, everything is faked that you want to be faked. No,
I'm saying that if one thing is fake, it's possible that other photos and videos are fake.
Of course it's possible. Now provide evidence.
I just did.
Right,
they faked a shot of the Earth from 150,000 miles out.
Which shot? This shot? No,
not
this is the one. This is the one that you asked for proof. This is our evidence. This is evidence, and now you're saying a different picture was faked, therefore this one is faked. No. You can't say that this one is faked because a different one was faked. You have to somehow show that this one was faked.
So if you go to a car lot and you pay $50,000 over value for a car because you got swindled, and you find out when you left the lot, are you going to go back to that car lot and buy another car from that place?
Poisoning the well. That doesn't matter. You don't get to say that every single thing that I want to cherry pick from this other organization that I don't trust, I get to throw away.
Picking.
What's that?
Who's cherry picking?
You are, because you are saying that whatever evidence from NASA you want to discredit, you can discredit just because one other thing was proven to be or shown to be faked, which I don't know if it was or not.
It's many things.
It's many things.
Have you seen the videos of the astronauts on wires on the supposed ISS? You've seen those videos, right?
I've seen all of those, and they're fantastically great, and they're not wires.
They're absolutely wires.
All right, evidence.
All right, let me bring up one of the videos. We'll watch it together, and then let me see.
So the hour-long video where they're floating around and doing flips and having things floating, you need to also have that one showing all of it is on wires.
Wait, but why are you worried? I thought you're not worried about them being on wires, so why would you care how long the video is?
It matters because you have to show that it all is fake.
So here, I'll share. Are there any cuts in the hour-long video?
No.
There's no cuts from shot to shot.
Nope. It's one solid. It's more than an hour even.
Interesting.
No, I don't have it. I don't have it on handy. Maybe somebody in has it.
All right.
Yeah,
So
I've seen this one. I've seen this one. Yeah, this isn't anything. He does a flip. This disproves wires.
Just relax. Let's just watch it together, and then you tell me what you see, and I'll tell you what I see. Okay? You ready? Here we go. It's at the bottom. What's he grabbing on?
Don't know. It doesn't matter. How did he just do a flip?
He's on a wire harness. So the guy clearly grabs on a wire or a cable or whatever you want to call it on the side of his hip. Let's just pause it right there. You can see, and it drags and pulls the pant to the side. Let's just go back. So here the pant is not sticking out at like a 95-degree angle, and you can see his hand getting ready. And then when he pulls on it, that's a bad stop. The pant goes out. Let's see if I can get a better stop. So I mean, look again. We're looking at the same evidence, and apparently we're seeing two different things. So I don't know. That's like I say, we're at a stalemate in a lot of things. It's just I see him pulling on an invisible wire. Like I don't know what to tell you. The guy visibly moves when he pulls. Like you can see him sort of jerk a little bit. So I guess you could say he like pulls on his pocket if you wanted to say that.
So you found one anomaly.
Well, no, it's not. It's there again. It's many anomalies. That's one of the most obvious ones. Like this lady's pulling on her pants because whatever she's attached to is pulling her up. You can see it move right here on her back.
But the rest of the entire rest of this video is doesn't work if they're on wires. It's just
no, that's not true.
Her hair.
Yeah, it's ridiculous. What's this guy grabbing? Have you seen this one? The guy like grabs nothing and he puts it away. Like he thinks he's seeing something. This guy right here, he thinks he's grabbed something.
Pause it when he's not holding the microphone. You see, you take this one little piece that doesn't kind of make sense to you, and you ignore that the microphone is just floating there.
Well, but no, that's not even the part of the scene. Like he thinks he's grabbing something.
There was he keep going until he lets go of the microphone.
All right.
There's the hat flipping around. How did that hat flip around on wires? How's the microphone float there with wires? None of that makes sense.
You see him grabbing. He thinks he's grabbing, I don't know, the hat or something and putting it over here, and he doesn't grab anything.
Yeah. Do we have the context of the video? What he's doing? You think he's grabbing something, but you're ignoring the hat flipping.
No, I'm not ignoring it.
You are. How is that hat flipping? Where's the wires for that hat flipping?
It could be some sort of 3D animation or something, or effect.
It could. All right. You have evidence for that? So I don't go on could be.
Well, this whole situation is it could be. Like they could be in space. They could have taken a picture from space, but I mean, what evidence is there? There's two guys apparently hanging or floating, and this guy grabs at nothing and switches hands and then pretends to put it away. Like, why would he do that? This guy is pulled on a wire. This woman has wires running up her back. You can see it here moving. Like, it just doesn't make any sense. Like, you could, I've even thought about other logical explanations. Like, they say that they send these people to space, but they don't. But they want them to feel special and say, oh, look, this person who clearly isn't looks like a computer geek, like he sits at a computer all day, is in space. Like, okay, to make him feel special and proud or whatever. They're clearly not astronauts. They're not in space. They're on wires.
See, that's all just speculation and no evidence. It's just, that video sort of looks like that, but I'm going to ignore all the other stuff in that video because it doesn't support my predetermined selection of what the outcome has to be.
What's the predetermined selection?
You've predetermined that the Earth must be flat, therefore everything else has to go along with it.
No, I didn't predetermine that. I was a ball earther for 33 years.
That doesn't matter. Since you made that decision, everything else that you've seen as evidence, you've ignored if it doesn't support your predetermined choice.
No, that's not true. In fact, one of the conversations I started, I said, I don't know what the truth is anymore because I've seen evidence on both sides, and that's the horizon rising or not. Here's another one. You can see the shirt lifting up on its own.
But what about the guy floating there? Right?
These two guys?
You ignore the stuff that is just
These two guys?
yes.
Well, they're on harnesses.
But he's the best gymnast ever to have to keep his knees up like that while he's on a harness.
That's why his hand's on his leg. You see? His hand's on his knee there.
All right, so this is evidence that it's flat. So,
No. It's evidence that we cannot prove the shape of the Earth by using sources from NASA. They're shown that they cannot be trustworthy. Anyways, I don't know.
All right, that's fine.
There's a ton of these videos.
So what about
Mark Sargent has the thing where he says if you prove the Earth is round without using NASA. And I'm like, I think that's fine.
Oh, I can do that.
Why would you use a government source to prove something when the governments have been lying to populations for ever?
I can do that.
All right. Hey, by the way, I maybe 5 more minutes. I know I said it like 30 minutes ago, but I'm really gonna have to go here soon.
All right. Well, then can you explain the southern celestial poles?
I mean, there's alternative. Again, it's all about, to me, alternative explanations. There's alternative explanations for it. I'm not articulate at them. I don't fully understand them. There's a guy who uses like a little glass dome thing, and he puts that over some lines, some paper, and he gets two celestial poles that way. So you could argue, well, there's a dome, or you could argue that the atmosphere has some alteration to stars and star trails. But again, it's not my area of interest. So
okay, but it's something that you maybe should address, because it doesn't have a good explanation. That there's nothing that nobody's ever explained it well, right? Eric Dubé's video on it was terrible. He made all sorts of claims that simply isn't true about what people in the southern hemisphere see, right? There's 800 million people that live in the southern hemisphere, and they look due south every day. Sean Hawkins, I'll thumbs up the video if you play the 45-minute video. No, I don't need to play a 45-minute video of the ISS right now. Crap, you interrupted me, Sean. What was I saying? The Eric Dubé made claims there's 800 million people in the southern hemisphere. They all look due south every night right? And they don't all look due south every night, of course, but when they do, they see the southern celestial pole due south, no matter where they are. So if it doesn't matter what map you take, if you take the AE map or any other map, due south has to look at the same spot. They can't look in opposite directions. I'm not showing you myself, actually. But, darn it. You didn't see my hands. Anyway, they're not looking in the same direction. And so you have a big problem there, because a flat surface doesn't explain that at all. So maybe that'd be a challenge for you to look at.
The same stuff at the same time. That's the problem.
Oh, of course they are.
No, like if you're not, let me look at a map. If you're like, what is it? If you're in Australia, and you're in
South Africa and Australia have nighttime at the same time.
They have night. Well, yeah, but
they have overlapping night.
Oh, overlapping night, right?
So they can both at night see the stars at the exact same moment, and so you can stand there. You can stand in Johannesburg, and you can look due south, and you can see the South Celestial Pole, and you can see slightly off center the South Celestial Pole, their favorite constellation, the Southern Star, the Southern Cross. And you can stand in Perth, and you can look due south, and they're quite a few degrees off. They're 40, 50, 60 degrees off of each other, and they can both look directly due south at the same moment, and they both see the South Celestial Pole and the Southern Cross at the same time. And if you take a picture of that, a time-lapse picture, right, you see this. Right, so here's the star trails above Table Mountain in South Africa. You can see this is clearly not the North Celestial Pole because there isn't Polaris very close to the middle, right?
Sure, then, or you could see that mountain range is in South Africa or whatever. Yeah.
Yep. And then you can go to Australia, and there's lots of these pictures. This doesn't take. I mean, you can look up if you have any questions about whether or not these are. There's lots. It wasn't hard to find. So there's Australia, and then here's one in South America. So 3 continents, very far off of each other.
All at the same time?
All, well, they overlap. So any 2 of these would have overlapping night times. Right? South America is going to overlap Australia, but when they're overlapping,
it does work on a flat Earth with rotating stars, right? I mean, if the stars are rotating, and you're, let me pull up a flat map. Oh, hold on, I did it wrong. No, I'm not even.
I have a map.
Okay, so pull up a flat map. Like, if you're in.
There you go.
If the stars are rotating around us, for example, and you're in South Africa, and you look to your west. Well, let me see.
No, you look due south. In South Africa, you look due south.
Right. Okay. Let's say if you looked due south in Africa, and you saw, let's say you were perfectly in alignment with the star, with the Southern Celestial Pole, you would not look due south in South America. You would have to change your angle, or if
according to this map. But in reality, they look due south. That's the thing.
Well, I mean, but what evidence do we have of that?
I showed you 3, and there's 800 million people that live in the Southern Hemisphere, right? I'm not gonna. Well, that's the kind of thing that if you want evidence, you can go get it yourself. That's pretty sneaking easy to get.
Well, it's a claim that at the exact same moment in time, maybe it's 3 o'clock here, maybe it's 9 o'clock there, whatever. But at the same moment on Earth, that each of those 3 countries do south.
It doesn't even have to be the exact same moment, but because here's the critical thing. From when it's first that you can see the stars until, from dusk until dawn, the Southern Celestial Pole never moves. It's always directly right in the same spot the entire night for all places that can see it. It's always in the same place.
It has to move. Well, even if the Earth is rotating, something's moving.
The center of that rotation does not move. The center of it does not move, right? The stars move around it, and they're the ones closest draw close, tight circles, but the very center of it doesn't move. Right? So that's the thing. Like, you're just saying, what if it doesn't? And like, you're trying to not believe it. But the thing is, there's 800 million people that live in the Southern Hemisphere, and they can all tell you the same thing. Yeah, when I look south, I see the Southern Cross, and it's in the same place every night, pretty much, because it's not exactly in the center. And anybody can do the same thing with a camera and take that same star trail picture and see the same thing.
Sure. So what I'd be interested in is a picture from those 3 countries at the same moment in time, all looking due south.
But like I said, they don't have to be the same moment, because the key is it never moves. It's not like, well, you see it now, and now nighttime is over for you, and then click, it moves over so somebody else can see it, and now No, nighttime is done for them. Click, it moves over to another place. That's not the thing. It's always due south for everybody all the time from dusk till dawn. So you don't have to do it simultaneously.
But if the Earth is spinning,
Yeah.
It's true relatively speaking. But it's not true if the Earth is spinning.
It's absolutely predicted by a spinning Earth. It must happen like that on a spinning Earth. If it didn't happen like that, that would be disproof.
If you had your camera pointed due south for 6 hours,
yeah,
you would catch some of it, and then you would lose it because it's rotated out of the way.
No, it doesn't rotate out of the way. On a spinning Earth, when you look due south, you will see the southern celestial pole.
Yeah, but
if you're south of the equator,
you'd have to adjust. You'd have to continuously adjust your camera.
No, you would have to not adjust your camera. By definition, you must not move the camera. Once you see the south celestial pole. And I think you're not understanding how a flat Earth would work, or how a spherical Earth would work. So I have right here. So here you go. Here is.
I'm looking at your computer screen, your flat map.
Let me change what you're looking at here. So I see two of me. We don't want that. These dumb. I got these. My other glasses I couldn't find, so I had to get these. All right, I'm gonna have to do this. There you go. All right, here is Antarctica. Right now, somebody over here in Australia is going to look due south, right, and then whatever they see. So the south celestial pole is going to be out there, off of this, right? And so somebody up here in Australia is going to look due south, right, this way, and see the south celestial pole. Somebody in South America is going to look due south this way and see the south celestial pole.
Right now,
and same thing for South Africa here, right? They're going to look
due
south.
As you spin on the ball Earth.
Yep. And so this line. This line coming off right here, this is the theoretical line of the south celestial pole, right? Goes straight this way, right? And it meets up with the center of rotation, which, well, it doesn't meet up with that. It's just a arbitrary point, right? And as it spins, everybody sees, but this doesn't move. They move around it, and so the camera that's looking this way is going to be looking this way, right? And then it's going to be looking this way, and then it's going to be looking this way, but it's still at the center. It's still in the same point to them relative to them.
Yeah,
so it's a necessity on there, and people.
So can you see that 24 hours a day then?
You can't see the stars 24 hours a day because the light of the sun blocks it, right?
Right. So then, we don't know for certain that the star trails are there during the day versus moving and spinning around us.
You're right. We don't see them during the day, but from other positions of the Earth at the time, you can see them, right? So when it's daytime in South America, it's nighttime in Australia, so they can see them and confirm they didn't disappear.
Right, but by that point, they would have spun around to that side, right? You see what I'm saying?
No, they would still be directly due south.
But you just said we can't see them during the day, so how do we verify that that's true?
Because we can see them from other places at the time. When you can't see them in South Africa, you can see them in Australia. And to suggest that they might move, to suggest that they might have moved or gone away or hidden themselves somehow is quite a stretch, right? you'd have to come up with some really
Well,
really great explanation for
it's
what happened to them while you weren't looking at them.
well, if you okay, so you know the flat Earth model says the sun and stars and moon are moving around us, right?
Yep, I do, and
So then it's not a stretch on that model. And by the way, the geos, I would if I were not to become a flat earther anymore, I would immediately become a geocentrist, because that's what we observe. We observe everything moving around us.
well, it's a step in the right direction.
Well, I'm just saying that's an actual. If you don't like the flat Earth model, the geocentric model is the equivalent of the heliocentric model, but with the Earth in the middle and everything moving around us. And in that model, you absolutely cannot tell the difference 100%.
Except there's a lot of observations that don't work. But that's once you're there, we'll talk about that.
Well, and then again,
but
that's why
no.
I don't like going to the stars and that. I mean, it's just not.
And
just not
that's why
interesting.
I love going to the stars, because it.
Well,
and
but it
I know,
doesn't-
and flat earthers don't. This FE News guy has been in the chat all night here. I did a video this weekend using this flat Earth map. Well, the one that was up that you can't see right now, right? To predict where the sun would be on the summer solstice in North America, and it would necessarily.
I saw that video. Your video, it's
and it's not. It wasn't there. The sun wasn't there.
Why would you expect it to be there?
I would absolutely expect it to be there 21 degrees above the horizon, because that's where perspective demands that it would be. Because we can calculate perspective. And I gave a link, and you probably didn't look at it. I gave a link in the video and I'll pull it up right now quick.
So
here
what
we
numbers did you use in your calculation?
We can do the math right here. Here is let's see, Minneapolis right there, 45 degrees north, and the sun would be about over Myanmar, right, at midnight on the day of the northern solstice, which was just a couple days ago, right? And there's a distance. What's that?
You're on you're showing camera, not screen.
Oh, darn it. I forgot how I did that. Yep, I'll get it. Do you see it now?
Yeah, I see it.
All right. So you see Minneapolis there at 45 north, and then there's the Tropic of Cancer, and then the sun would be directly over Myanmar at local solar midnight, so the middle of the night in Minneapolis, right? And so we can calculate the distance is pretty easy, because each degree of latitude is 69 miles. So you go from Minneapolis to the North Pole, which is right in the center. That's 45 degrees, which is 45 times 69, and then we're down to 20. So it's going to be, what's the Tropic of people? What's the Tropic of Cancer? Anyway, the latitude, right? You just take the degrees of latitude there and multiply by 69. You get 7,676 miles away. If the flat Earth map is correct, that's where the sun must be, because we know, because people live in Myanmar and they know where the sun is directly overhead on the day of the solstice, right? That's confirmed. There's nobody I've ever seen that disagrees with that. So it's 7,676 miles away. So if the sun is 3,000 miles high, but you can pick whatever number you want. But if it's 3,000 miles high, we get an elevation above the horizon, or actually above true level, of 21.35 degrees. It cannot be down. And I know you're thinking of this picture right here, or a similar one with light poles, right? Everything above the eye converges down. Right? That's how perception works. That's how perspective works. And we can calculate it. And that's what I did. I calculated where it would be. And it would be 21 degrees above the horizon. We can go to The same thing on the southern solstice, 6 months from now, at the farthest south point of South America, which is as far south as you can go before you hop over to Antarctica, right? They're 54 degrees south. The sun is 17,000 miles away. That gives you an elevation of 9.53 degrees above the horizon. In the middle of the night, on the most aggressively friendly to the flat Earth number that there is. Right? That's the lowest that it could ever be anywhere on Earth, 9.53 degrees, other than Antarctica. Yet, now I've not gone to Puerto Williams and I've not spoken to anyone there, but I would figure that if they saw the sun in the middle of the night, they would say something about it. And certainly that doesn't match with suncalc.org or timeanddate.com, things like that people look at all the time to see when the sun rises and sets. It doesn't match any of that. And again, I've never seen anybody argue that that those numbers are wrong. The sun does set, right? It does go down. It is gone for hours before it comes up in a different place, right? And so how does that happen if the Earth is flat? There's no valid explanation. The magic lampshade doesn't do it because it actually goes to the horizon. The distance from the horizon doesn't match because it traces a very unusual shape that isn't based on distance, right? Because the North Pole would be one of the warmer places, one of the places that got the most sun on the flat Earth map.
So there is an explanation for it that I've seen, but I'm not gonna tell you. I'm gonna link you to a video to watch because I do have to go.
Okay.
And that would just take us down a whole nother rabbit hole.
Sure.
But,
all right. There's one question in chat that people have been asking that we brought up before. So I was talking about it before you got here. I was talking to a lady at work about the flat Earth, and I asked her. She said, well, the Earth isn't flat because if it was, everybody would want to go to the edge. And I know not everybody thinks there's an edge, but all the guys would want to go to the edge and pee off the edge. There'd be luxury trips to go to the edge to go pee off of it. Everybody would. And so in the chat, people all agreed, all the guys at least did, that they would want to pee off of it. So if there was an edge, would you want to go pee off it?
Sure, why not?
Thank you.
So I think the interesting thing on this video is it explains both sunsetting and north and south. God damn, I'm tired. What is it called? Not circular star trails or whatever.
Sure. Is it from Eric Dubay?
No, it's not from Eric Dubay.
Okay, because his is crap. Yeah.
I posted it in the side chat if you see it.
Let me grab it. I'll copy it to the.
Yeah, I'm not an admin on your, so I can't post it on YouTube. But so yeah, check it out and let me know what you think. So thanks for having me on, and it was a good talk, good debate, whatever you want to call it.
Yeah, thanks for coming, and maybe some other time.
Okay, have a good one.
All right, thanks. Bye.
See ya.